everyone, welcome back to another video of LeetCode Daily Challenge Streak series, and today we have another LeetCode medium question. So the question says, two strings are considered close if you can attain one from the other using the following operations. Operation 1, swap any two existing characters. Operation 2, transform every occurrence of one existing character into another existing character and do the same with the other character as well. Okay, now let's first understand what these operations mean. Operation 1 says we can swap any two existing characters. If there's something like A, B, C, if we want to swap A and B, we are just swapping its positions. So this becomes B, A, C because we just swapped B with A and vice versa. So this is operation 1. Now, what does operation 2 say? It says that you can transform every occurrence of one existing character into another existing character and do the same with the other character as well. So, if we take another example, A, B, C, C. Now let's understand how transformation with this scenario works. What we can do is that if we want to transform A into C and C into A, we can just, exchange the frequencies of these ones with including the places. So A, B, C becomes C, B, A. So C transformed into A and A transformed into C. Okay, this is operation 2, transformation, and swapping is just interchanging of the places. Now we are asked to see if we can perform these operations and transform one given string into the second given string. Now let's consider an example, ABC and BCA like they've given. Now, to convert ABC into BCA, what can we do? We can simply swap the places of the respective elements in 2 steps and then we'll have our answer. So let's first swap A with B, so that will give us B, A, C. Now let's again swap A with C and C with A. Now this will give us B, C and A. Now from A, B, C, we have our respective given second word. Okay, now let's take a different example, which is A and AA. Now, can we transform this A into AA? No, we cannot. Why? Let's go back to the operations. What operations are we allowed to perform? We can either swap the characters or we can transform with an existing character. But the number of letters we have in this first word is just 1 and the number of letters we have in the second word is 2. So there is no way we can either transform this or swap it within the given words. So the first condition that we can get out of this is that if the length of the word 1 and length of the word 2, if it's not equal, then we'll be returning false. According to the question, we can either swap or transform the existing characters. We can only do those 2 operations. We cannot add extra characters. We are not allowed to add extra characters. Okay, so by this we can conclude that if the length of the given words is not same, then we will return false by default. This is the first condition that we are supposed to remember. Now, let's take a different example, CABBA and ABBCCC. Now, if you carefully observe here, what is done here? Okay, what can be done to transform this into this? Now, let's just swap the characters. Did I write? Okay, there's a B missing. Alright. So we have C, A, B, 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 A. Now, let's just swap the characters. Let's swap B with A by performing operation 1. So we'll have C, A, B, B, B. After transformation, after step 1, we have C, A, B, B, B. Now, what we can do? We can transform these characters. Okay, so what will we have after transformation? So B will take over C and C will take over B. So we'll have B, A, and since C will be taking over B, we'll have C, C, C. Now, we still have one more step left. Why? Because we are still yet to get A, B, B, C, C, C. Now, the C, C, C part is done. Now, we are yet to finish this part. So, we can again transform this into this, A into B. So, A becomes B and B becomes A. So, B becomes A and A becomes B, B, C, C, C. Now, this was step 2 and this was step 3. Now, do we have our final answer? Yes, we do have our final answer A, B, B, C, C, C. So, after taking 3 examples, what all conclusions can we draw for solving this problem? Number 1, the length of the words should be same. Okay, that's the first thing, because if it's not the same, then we can't perform the operations. Now, what is the second thing? The second and most important observation is that the letters in both the words should have same set of letters. Okay, the letters in both the words should be of same set. Like if there is A, B, C in first word, then same set of letters should be there in the second words as well, which is A, B, C again, irrespective of their order. Like they can be C, A, B, or they can be anything. But the letters that are repeating should be the same. That is our second conditions. So letters should be same in both words. Okay, now for the transformation operation to be done, we have to check something. Now what is that? We will consider another example, the same example, and then try to understand what else should we check. Now let's take the example word 1 being C, A, B, 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 A, and word 2 being A, B, B, C, C, C. Now, for the transformation to be done, we have to check for the frequencies of the element. Okay, frequencies of the element. What did I tell you earlier? I told you that the same set of letters should be present so that the swapping or the transformation to be done. Now, along with the same set of letters to be present, their frequencies also should match. Not the respective letters, but at least the frequency numbers of any element should match this frequency element of the other set. Okay, let me just explain it in a better way. Now, what is the frequency of C here? It is 1. What is the frequency of A here? It's 2. And frequency of B is 3. Now, what is the frequency of A here? It is 1. And B is 2. And C is 3. Now, the transformation can only be done, as in the transformation can only be done. If I want to write BBB as CCC, if 3 letters are present here, then I should also have 3 letters of something here for swapping or transformation to take place. Likewise, if I want BB here and if I have AA, okay, if I want to write B into A, like, okay, in a better way, to explain it in a better way, now I have AA and I have B. Now by applying transformation, I can convert this AA into BB and this B into A. Now, this is only possible, and this is possible when I have same set of frequency numbers. Okay, I will be able to achieve my final word A, B, B, C, C, C if and only if I have the same set of frequencies, because I had AA here and I had B here, which is why I could write AA as B and B as A. If I had something like AA and BB, and if I wanted something like just ABB, I wouldn't be able to transform it, because even if I were to transform these among themselves, I'll be getting BB and AA. But what do I want? I want ABB. Here the frequency of B is 2 and the frequency of A is 1. Okay, but I want frequency to be 2 and 2. So this is not possible. So the frequencies should be of the same sets for my word to be transformed into one word to another. I am hoping this part is very clear. So the frequency sets must be of the same elements for the transformation and swapping to happen. Now let's quickly write the third part down. The word's length should be same, then letters should be same, like whatever elements are occurring they should be same, and their frequency counts must be same. It doesn't matter if A is 1 in one thing and A is 2 in different thing. As long as B is 2 and B is 1 here again, as long as they are matching their frequencies here, it should do the job. Okay? Now, let's quickly understand how to write the code with these 3 points. Now, I also told a default point earlier. Okay? Now, what can we do? So, the first condition is if the lengths are not same, what do? We return false here. Okay? We return false if lengths are not same. Next, the letter should be same in both the words. To check those letters, what do? We will have two sets, S1 and S2. Okay? Then, since we have word 1 and word 2, what we'll do? We will iterate over the first word and store them in a set. Just so we don't have duplicacies. Now again, for S2 set, we will iterate over the word 2 and store the elements in set 2. And if S1 is equal to S2, it means that all the elements of word 1 are present in word 2. Then we can proceed. If the elements are not same, then we can't proceed. Why? Because if I have something like A, B, C, and if I want to transform it into A, B, C, D, I can't do it because it has an extra letter D and I can't add extra letters. I can either only swap or transform. So, this is our second check. Now, the last thing is to check the frequencies. Okay, we'll check the frequency of both the elements occurring in word 1 and word 2 and store them and store their counts alphabetically in their respective indices. If it's 1 here, then we'll initialize them to 0 first, like 26 letters, since we have 26 letters, and here also we'll initialize 26 letters 0 0 0 array, and then we'll check the frequency and update the count. After updating it, we will sort it. Okay, we will sort it. If after sorting, we will compare the frequency arrays. If they are same meaning same set of letters are occurring, like I told you, same set of letters are occurring, then the word can be transformed into the second word. If the frequency arrays are not same, let's say one array has 1, 2, 3 and the other array has 1, 2 and 4. What did I tell you? We can't add an extra element to make this the second word. So, this will return a false. So, what all conditions will return true? If the length of word 1 is equal to length of word 2. Let me take a different color for conditions. If the length of word 1 is equal to length of word 2 and if set 1 is equal to set 2 and if frequency of 1 is equal to frequency of 2, that is when we will return a true. That is when a given word can be transformed into a second word that is given. If any of these cases fail, it means that we won't be able to transform the given word into this. We won't be able. If all those 3 conditions pass, then we will be able to transform. Otherwise, we won't be. Now let's quickly code this up. We have a function close strings given, in which we are being given 2 inputs, word 1 and word 2. Okay. Now, what are we doing in the first step? We are creating 2 frequency arrays to store the frequency of each element occurrences. Okay. each element occurrences. So frequency 1 is equals to, we are initializing it to 0 with 26 elements, and same with the frequency 2 array for the second word, we are initializing it to 0 with 26 elements. Now next, what are we checking? We are checking the length of the two words. What was our first condition earlier when we discussed? First was to check the length. Second was to check the elements present in the given words are same or not. The third is to check if the frequency occurrences, the digits, are same or not. So for the first thing, let n be the length of word 1 and m be the length of word 2. Now by default, if n is not equal to m, then return false, our first condition. Next we have to store the frequency of each element. For that, let's initialize an element to 0 so that in while loop we can simultaneously go through word 1 and 2 and update in frequency 1 and frequency 2 indices respectively. Now while I is less than n, why n? Because we are, since the length is same here, if it's not same then we already exited it if the condition is false. Since the length is same, we are going forward. Now, so we are updating the frequency of the first word elements in frequency 1 by doing this ord method in word 1 of element I, okay, and ord of a, plus we are incrementing it by 1, like whatever element that we are going to come across, we are going to increment it by 1. Now we are going to do the same frequency 2 and incrementing it word 2 array and incrementing it by 1. Now also will be for moving to the next element, I plus is equals to 1. Now we store the frequencies. What are we doing next? We are seeing if a is present in frequency 1, we have to see it should be present in frequency 2 as well. Okay, if this index element is 0, as in if a is not present in frequency 1, then its frequency will be 0. Correct. If a is not present in frequency 2, then its value in the array will be 0 as well. So to see whether or not the element exists in both the things, its respective index values in both these things should be same. Otherwise, we will return false immediately, because if it's present in one word and if it's not there, then the condition won't pass. Now, the second thing. We are checking for this, and if in case in frequency 1 array the element is not there and in frequency 2 array we have the element, meaning it is not 0, okay, or if it is present in frequency 1 array, okay, meaning not equal to 0, but it is not present in frequency 2, meaning the frequency 2 array frequency 2 array will be 0. Okay, then what will we return? We will be returning false. Why will we return false? Because in either of those one element is absent, which is why we are returning false. In this case we are returning false, in this case. Now what is the last case that we are going to check? We are going to check if the frequency digits, if 1 or 2 or 3, if it's same or not in both the arrays. For that, let's sort our arrays first and compare them directly. Okay, we will compare them directly. Okay, if frequency 1 not equal to frequency 2, what are we doing? We will return false. Otherwise, we will return true. Okay, let's just quickly run this code. Something frequency 1 it is. Let's run it. Accept it. Let's submit it. Okay, and this works. Okay, talking about the time complexity. Since we are iterating over the elements of size n to store those frequencies, we will be having a time complexity of O of n because we are iterating over the words of size n. Now, what is the space complexity? The only array, the storage that we are using here is a frequency array of 26 elements of fixed size. Since it's of fixed size and 26 is a constant, the space complexity is big O of 1. Thank you guys.